Welcome to the last lesson of Chapter 3. What we're looking at in Section 3.4 is solving problems using acute triangles, or in other words, just problem solving using the sine law, using the cosine law, using the Pythagorean relationship, using all of the tools that we've learned in Chapter 3 so far. In lesson number 1, we looked at an example where we were determining if we were using the sine law or cosine law to solve, and we looked at the first word problem, which was solving for the height of a totem pole. We are just going to do 2 more problems, and again, the goal of this lesson is just to enhance your problem solving skills and just to have you thinking about a few things. Example number 2 says this: a regular octagon with center O is shown. If the distance from O to a vertex of the octagon is 12 centimeters, determine the perimeter of the octagon to the nearest tenth of a centimeter. Now, at any point in time where you feel like you might be able to do this, you may want to pause the video and play it later to see if you're doing it correctly or if there's a different method to get to the correct answer. And there's many methods to get to the correct answer, which is kind of useful. But what this is saying is that from center O to a vertex is 12 centimeters. And we want the perimeter of the octagon. The big idea here is if we can find this blue length here, since this is a regular octagon, we could just take that length and times it by 8. So the goal is to find out that length. Many ways to do it. Again, I'm just going to show you one of the many ways. You might want to think about this a little bit by yourself as well. Here's one of the many ways. If you would like to, you could draw all of these lines from the center O to each vertex. I'll describe why that might be useful to you or why it might not. And again, if you think you might be cluing into it, you might want to stop this and try it on your own. One thing that we learned in Chapter 2 is that angles at a point meet at 360 degrees. So one thing that we could do is we know that all of these add up to 360 degrees. So we could find one of them by dividing 360 by 8. So in other words, this angle here can be found, if we'd like to, by doing 360 divided by 8. And 360 divided by 8 is 45 degrees. So that angle there is 45 degrees. If you want to think about how that might be helpful, you can go ahead and do that. But this angle here is 45 degrees. And we also know that this side length here is also 12 centimeters. So here's one method that you could find out that blue side, or maybe I'll just label it with an X. One method is by using this triangle here, and at this moment you could use the cosine law. So if you'd like to, you could go ahead and do that. I'm going to show you an alternative method, but the cosine law says that a squared is equal to b squared plus c squared minus the product of 2 times b times c times the cosine of a. And in this case, we're solving for x. And the two sides, b squared and c squared, would each be 12. Again, this is one of many methods that you could use. And I'll just show you another one in just a second. That would be times the cosine of 45. So go ahead and do that if you'd like to. Here's an alternative method. If you would like to, we know that this is an isosceles triangle because both of these sides are equal. So if we like to find these angles here, what you could do is 180 minus 45, that's a total of 135 degrees, and then divide it by 2, which is 67.5 degrees. So we know that each of these angles here, and you can think about how that might be useful, is 67.5 degrees. Again, many methods to get to the same result here. So those are each 67.5 degrees. What I'm going to do is, if I call this x, I'm going to use the sine law. X is opposite 45 degrees, and let me use a different color. 67.5 degrees is opposite 12 centimeters, and you could use the sine law. So all sorts of ways, and again, you might want to pause this video and try it yourself to solve for the length of x. So I'm going to set up x is over sine 45 is equivalent to 12 over sine 67.5. And the algebra that we do here is multiplying each sides by sine 45. And go ahead and calculate that on your calculator, hitting equals as often as possible. So 12 divided by sine 67.5, hit equals. And now times sine 45, hit equals, and the length of x is roughly 9.2. And in this case, we know that the perimeter is equal to 9.2 times 8 sides of the octagon, which is 73.6 centimeters. All right, let's look at our last problem. I'll read it to you. This problem says, two fires are 45 kilometers apart from each other. Fire A is directly west of a helicopter and fire B is directly east of the same helicopter. So here's a bird's eye view of what's happening. We've got a helicopter from above, and to the west is fire A and to the east is fire B. I'll point out why this is a problem at the moment after we're done reading the problem. It says the angle of depression from the helicopter to fire A is 15 degrees. If the helicopter is 30 kilometers from fire A, how far away is the helicopter from fire B to the nearest tenth of a kilometer? What is the angle of depression from the helicopter to fire B to the nearest degree? So we actually have two questions to answer. The problem with the bird's eye view is when we're using an angle of depression, that means an angle down from horizontal. And at this moment, we don't have a triangle. We can't see down from horizontal if we have a bird's eye view. So here's the actual diagram that we're going to use for this problem right here. So if we are looking at it from the side, or in other words, I could put here ground level. This is a more accurate view of what we're seeing in this problem. So this is from the side, from ground level. A is to the left of the helicopter, B is to the right of the helicopter, and if we're looking at the angle of depression is down from horizontal. So that would be this angle right here is 15 degrees. And then it says if the helicopter is 30 kilometers away from fire A, so here's 30 kilometers, how far away is the helicopter from fire B? So we're determining this length. What we also know from the very first sentence is that the two fires are 45 kilometers apart. So here's the most accurate triangle I can draw from ground level. In this case, you might notice that we don't have any angles in this triangle, but again from chapter 2, and here's where the problem solving comes in regularly. From chapter 2, we know that if we have parallel lines, which these two are, the ground is parallel to the line of sight of the helicopter. If those two are parallel, then what we know is that alternate interior angles are equal. Okay, so again, you're going to have to use some problem solving strategies. So we know that this angle down here is 15 degrees. Okay, so one of the big ideas is just to do something when you are starting these problems. Now in this case, what we actually have is this triangle, and we could solve for x using the cosine law. So we're going to use cosine law in solving for x, and in this case we've had lots of practice with the cosine law. Here's what it would look like. X squared is equal to 30 squared plus 45 squared minus 2, sorry, that should say squared here, minus 2 times 30 times 45 times the cosine of 15. And you may want to again pause this video to see if you can get the correct answer before you watch me do it in the lesson here. So all those products are what you are going to want to do first. 30 squared is 900. 45 squared, I believe, is 2025. You can double check that. And finally, 2 times 30 times 45 times the cosine of 15 is 2608 roughly. Okay, so the next step is to determine this sum here. So we know that x squared is equivalent to 900 plus 2025 minus 2608. That's roughly 317. And as we know, the last step in solving for the side length using the cosine law is to take the square root. So x is equivalent to the square root of 317, which is roughly 17.8 kilometers. So that distance is 17.8 kilometers. All right, and here's the last problem. The last problem is asking us what's the angle of depression from the helicopter to fire B. So what we're doing is trying to determine this angle here. Okay, so that's the angle of depression from the helicopter to fire B. Now, what we do know, if you're paying attention to the first part, is that alternate interior angles are equal. So essentially, we're also trying to find this angle, because if we have that angle at fire B, we also have the angle of depression. So let's go ahead and see if we can solve for that. In this case, what I would suggest doing is you could use either the cosine or sine law. I'm going to use the sine law because I find it slightly more simple and for me. But again, you could solve this any way that you'd like to because we have all three side lengths. You could also use the cosine law. I'm going to use these opposites and these opposites. Okay, so in this case, I'm going to use the sine law. And we have here that sine of angle B over its opposite side, which is 30, is equivalent to sine of 15 degrees over 17.8 kilometers. And again, you might want to try and solve this yourself before finishing this video. So pause it if you'd like to. So we'll have sine B is equivalent to whatever this is calculated as. And again, press equals as often as possible. Sine 15, hit equals, hit divided by 17.8, hit equals, hit times 30 and hit equals. So I have 0.436211. 0.436211. So finally, in order to find out the angle, you're going to want to take the sine inverse. So B is equivalent to the sine inverse of 0.436211. And we'll get the angle, that angle B, or the angle of depression from the helicopter to fire B, is equivalent to about 26 degrees. So there's our answer. So in summary for this chapter, here's the key ideas. Basically, it's how do we problem solve. It says when solving problems involving triangles, the first thing we're going to want to do is sketch a diagram of the problem as accurately as possible. It's very useful to be accurate in these problems, and here's the reason. That way you can see if your answer is reasonable. So you can see if the answer that you get makes any sense, and the more accurate you draw your picture, the better you'll be. And lots of ways to do this. You can use the sine law in order to solve, as you know. You can use the cosine law in order to solve. You can use that angles of a triangle, sorry, that should say sum. Sum of angles in a triangle is equal to 180 degrees. You could also, if you want to, use the Pythagorean relationship. This only works for side lengths of a right triangle, but the a squared plus b squared is equal to c squared you could use. So many different methods. If you're in my class, what you're going to want to try to do is answer the following question below and get me to look at it when you are done.